Gauss's law, Resnick-Halley-Crane. Now here we have a problem where there is a hole in the large non-conducting sheet and we have to find the electric field on the axis of the hole. Okay, so there is a large flat non-conducting surface carrying a uniform charge density sigma, and there is a small circular hole of radius r that has been cut in the middle of the sheet, ignoring the fringing of the field lines around all the edges. It is given that you need not to consider about the fringing effects around any surface. You need to ignore it. Find the electric field at a point P at a distance z from the center of the hole along its axis. Okay. Now, what are the skills in this problem? If you remember, we don't have any standard formula for finding the electric field on the axis of a hole of a uniformly charged sheet. But we have the formula, we have the expression, we have derived the expression in our fundamentals for finding the electric field at any point near a charged sheet and also at any point on the axis of a uniformly charged disk. Okay, so we will apply basically the principle of superposition. We know we can add or subtract something, and the electric field of one object is independent of another object, so we can add and subtract and apply the principle of superposition. So what are the knowledge we are going to import from the fundamentals? So in the fundamentals we have seen, whenever we have a uniform disk with a density say sigma, and there is a point P on its axis at a distance z from the center. So if I am taking the outward model of the field, so we have seen in the fundamental, the field is along the axis, and this field comes to be how much? Sigma by 2 epsilon naught 1 minus z by z square plus r square under root. Correct? That is the first fundamental which we are importing from our basic knowledge. Say r is the radius. Okay. Second fundamental we have seen, whenever we have a large uniformly charged non-conducting surface, non-conducting sheet, then the field is perpendicular. The field is perpendicular to this non-conducting sheet and has a value of sigma by 2 epsilon naught, where sigma is the uniform surface charge density. So we are going to import these two key points for solving this problem. The problem is very simple, straightforward, no big deal. So what I will do, I need to find the electric field for this case. Okay, say I'm saying this is my object A. Now what I'm first making an object B. I'm just filling up this hole. The hole is, I'm assuming the hole is no longer there. Let us fill up the hole with the same density. Whatever I'm filling up in the hole has the same surface charge density as that of the surrounding sheet. So you will get this model, say object B. Okay, and this is something which we can treat as a large non-conducting sheet, and we can find the electric field on its axis. Interestingly, we have seen for this case the electric field is independent of the distance from the plate. So let this field be EB, correct? And what will be EB? So we'll get sigma by 2 epsilon naught, correct? Let it be equation number A. And then let us focus on a uniformly charged disk, say object C, with a density sigma, and here of course your field will depend on the distance. So there is a target point P at a distance z from the center, and importing that fundamental knowledge, this object I am saying C, so let the field at here be vector EC, and your vector EC will have a magnitude sigma by 2 epsilon naught, correct? And what you will get? You will get 1 minus z by r square plus z square under root. Let it be equation B. Got it? So basically we got the field for the large non-conducting sheet and the field for a uniformly charged disk on its axis. Now for case A, can I say case A is simply case B minus case C, or you can say when you combine case A and case C, you will get case B, correct? So same superposition and combination will be followed by the pattern of the field. So I can say A is equal to what? B minus C. So since same pattern will be followed by the field is because of the configuration of the charge and not because of the surfaces. So I can write E of A in vector form is E of B minus E of C. So I have to subtract EC from EB, and both EC and EB are upward. So it will be the 1D case I am taking upward as positive, and I can remove the vector sign, that's one dimensional case. So I'll get EA is EB minus EC, and of course if your field will come positive it will be upward, otherwise it will be downward. So I will get EA as, I can take sigma by 2 epsilon naught as a common factor. So EB will have 1 and EC sigma by 2 epsilon naught. So I'll get 1 minus Z by Z square plus R square, correct? So this will be the expression for the field for A. So EA will come to be, now 1 will get cancelled away and minus of minus will be positive. So we'll get sigma by 2 epsilon naught Z divided by Z square plus R square under root. So this is our electric field for the given problem. This is the electric field on the axis of the hole.